All right, go and have your homework out if you would please. You had 3 constructions to do last night for homework. You had a fourth proportional to construct, so that was construction 17. You had a mean proportional construct, that was the new one from last lesson, construction 19. And then you also had to divide a line proportionally to a couple of given segments, and that was construction 18. Go and hold up your homework so that I can see that it is completed. All right, flip that one over. Excellent. And over, good. And over. Is there a backside or is that all 3?
1, 2, 3. I think I did not one for the middle.
Yeah, especially the mean proportional shouldn't have looked like that. And then Adam, I did not see. Yeah, looks like you may have tried to do the same thing Abby did. All right, I think maybe you went with a third proportional instead of a mean proportional. I bet that's what you did. All right. Let's go and take a look at the homework then. We were supposed to have 3 line segments. One that was 1 inch. One that was 2 inches, and one, I get that on there, and then the last one was 3/4 of an inch, so a little small segment there. All right, so 1 inch, 2 inches, and 3/4 of an inch, and you were supposed to construct the fourth proportional. What do we need to do to construct the fourth proportional to 3 given segments? Josh, what do we do first?
Draw 2 big long lines as the sides of the triangle.
Good. We're going to start by drawing 2 big long lines, and good, not drawing them horizontally, but drawing them as the sides of a future triangle. All right, then what should we do, Abby?
And then you take the 1 inch, measure it,
All right.
and then mark it off on the right side.
Now again, in all fairness, I would understand if your thought was, well, why don't I just measure 1 inch with my ruler? After all, I measured 1 inch there. Well, because on quizzes and tests, I'm not going to give you lengths to measure yourself. I'm going to give you lines. So we're practicing to be ready for quizzes and tests. So we mark off the inch. It wouldn't hurt to go ahead and label. That's the 1 inch segment. All right, then what do we need to do, Adam?
You mark the 3/4 inch. The side 2 inch line.
The 2 inch. Go with whatever the second one is. We'll assume it's intended to go in order. So we'll measure off our 2 inch line and mark that off. All right, then what, Noah?
And then you measure the 3/4 inch.
Measure the 3/4 inch line. There we go. We'll mark that off as well. Then on the other side, good. All right, and then Dylan.
You connect the 2 points at the top.
Connect the ends of the top 2 segments, the first segment and the third segment. And again, in the drawing, this is the parallel, or what we used to refer to as being the parallel. All right, then what, Lana?
Then you make an arc on the top one, and then you copy it on the
Good, because we're trying to make construct a parallel line down here. So wherever this line is at the end of the 2 inch line or the second segment, we want to construct a parallel, and that requires equal angles, so copying the arc becomes necessary. And so we'll make the arc here, come down here to the end of the 2 inch segment, make the arc, measure across. Measure across this way as well. And when we connect the dots, we should get a line that is parallel to this one, and this right here is your fourth proportional. Did anyone happen to measure their fourth proportional to see how long it was? How long should the fourth proportional be, anyone?
1.5 inches.
Should be exactly 1.5 inches. Did anyone get 1.5 inches for that fourth proportional? All right, if I'm going to scale, it should be, I feel like I'm probably off, because that would have to be 12. Yeah, I'm almost a full inch, 3/4 of an inch off somehow. So could have been the measurement. I had a little trouble marking my 2 inch line. Somewhere along there was some error there. So I'm looking at about, 8% error. That's pretty high. Questions on this? How many had a construction that looks something like that? You did those steps, all right? Questions on the construction of the fourth proportional. All right, the next problem you were supposed to do used centimeters, and you were supposed to draw 2 line segments, a 4 centimeter line and a 9 centimeter line. Wait, I'm going to, sorry. 9 centimeter line would go out to here. If I'm going to scale, I'm doing 6 centimeters per centimeter. So 4 centimeters and 9 centimeters. Now, if we were supposed to construct the third proportional, we do what we just did. We draw 2 long lines that came off at an angle. We'd measure 4 centimeters. We'd measure 9 centimeters. We'd measure the 9 centimeters again, connect those, and draw the parallel. And we would get a really long line, about, 20¼ centimeters long, which is about the width of 2 hands somehow, or 2 sets of fingers if you were doing that, which is a little wide. I don't think it was supposed to be that big. But instead of the third proportional, which is not what I asked for, I asked for the mean proportional. How do we start that construction? Brandon?
Draw one big line.
Start by drawing one big long line. And remember, while the first picture we just did was based on top is to bottom is top is to bottom, I may want it longer than that. When I say big long line, I think this one really does need to be a big long line. All right. So this one was based on top is to bottom is top is to bottom. With this one, what we're trying to construct, class, is segment is to altitude as altitude is to segment. So Brecken, once we've drawn our big long line, what do we need to do now?
Take your compass, measure the 4 centimeters, mark it off on that line.
All right. So there's my 4 centimeter segment right here. All right. Then what, Josh?
Measure your 9 centimeters.
Measure the 9 centimeter segment, and what do I do with it?
Mark it off on the big long line in succession.
Good. Mark it off in succession, not starting here again, but going all the way here to the end of the 4 centimeter before marking off the 9 centimeter line, or the 9 centimeter segment. All right, Abby, then what should we have done?
Then you draw the altitude.
Which, since it's an altitude, it's going to be
The perpendicular of the 4th line.
good. Right here where the 4 ends and the 9 begins, right in between them, we'll do construction 4. We'll construct a perpendicular, which is going to be the altitude, as Abby pointed out. And so we draw our perpendicular here. Gavin's like, what's a perpendicular? Well, anyway, I don't remember who I'm picking on with that one.
Brandon.
That's Brandon in the perpendicular? All right. Anyway, he doesn't say it like that anymore. Now he always says perpendicular. He enunciates very well now. Anyway, sorry, Gavin. All right, so we construct our perpendicular, and which is going to be the altitude. And then remember, the key is that somewhere along this perpendicular would be the vertex of the right angle. So that I could, if I wanted to, draw lines that formed right angles to each other, so that here's your hypotenuse, these are the segments of said hypotenuse, and from wherever that vertex is, that would be the altitude on the hypotenuse. How do I locate that point, Adam?
You're going to make the bisect the line, the segment.
All right, how does that help me? He says we're going to bisect the line, and what he means, I believe, is the full 13 centimeter long, what will be the hypotenuse, right? I want to bisect the entire length of what would be the hypotenuse, but how does that help, Adam, to bisect that?
Well, you're going to make a semicircle with that line.
And so when that line, or rather that midpoint, is the... help anybody? The center of the semicircle, right? So I want to put a semicircle that starts here, goes all the way around to here. It can't just be an arc, it has to be an actual semicircle. So along here, the midpoint of this, remember, becomes the center of the semicircle. Now I think I may regret being so close to the chalk tray here, so I can't go too much bigger than half, but I think I should be good with these arcs. All right. And remember I said when we draw this line, class, either draw it very lightly or draw it dotted, right? One of the two. If you're okay with a dotted line, draw a dotted line. Really, The reason I would suggest go ahead and draw the actual lines, just to make sure it looks right, make sure it looks perpendicular, but you really only care about this point, this midpoint, because again, Adam, that's going to be the
midpoint of the center, or the center.
the center of the semicircle. Good. So from here, I just need to extend it out. You could go to either one of the ends. If it's the midpoint constructed properly, either end of the distance should be the same. And we'll get that semicircle. Do I have to draw the whole semicircle, class?
No.
I don't have to. It's not a problem to, certainly. But I really only care about this mark right here. Where does it cross the perpendicular? And this then would be, if I took the time to draw the lines here, okay, this would be the altitude on the hypotenuse. This is my mean proportional. How big should the mean proportional be, class?
6 centimeters.
Exactly 6 centimeters. Since I did 6 to 6, it should be 36 centimeters. And it looks like I'm about a centimeter off. So that's still, that's down around 3% error, which on the chalkboard, that's not bad. Questions on this construction? Yes, sir.
Yeah, I accidentally bisected the where the 4 left off in the 9.
Oh, so you bisected just the one piece
Yeah.
of it, and that's not going to allow
Right.
that. Then now your semicircle's just going on the one segment, right?
Yeah.
And that's no good. So yeah, remember, kind of picture where it's going. The 4 and the 9 collectively is your hypotenuse. These are the segments of the hypotenuse. The whole, what turned out to be 13 centimeters, is the hypotenuse. We need the midpoint of the hypotenuse.
I just put mine like on the perpendicular and did.
And so your semicircle went something
yeah,
like
and I was
here.
wondering why it wasn't.
Got it. Okay. All right. Good. Any other feedback, questions, comments? All right. How many say? I think I pretty much nailed it. How many measured and got 6 centimeters? Brecken, good. All right. Dylan, good. All right. Questions on mean proportional. That was the new one from yesterday. All right. And then the last construction I had you do was to take a 3.5-inch line and divide it proportionally into 2 inches and 3 inches. Not that you could divide it into 2 inches and 3 inches, but you could divide it so that the pieces that are formed are proportional. Now, to be fair, Adam commented that his compass couldn't open wide enough for some things. Well, you realize, class, if I make 2 inches to 3 inches, what's the ratio? But I could do that with 2 centimeters and 3 centimeters, couldn't I? I could. Now again, we're practicing for what would be on the test potentially. So if on the test, I actually did give you a 2-inch line and I did give you a 3-inch, finish it out there, a 3-inch line, you would just use whatever lines I gave you. But again, if you needed to do a scale drawing, do centimeters instead of inches, it'll shrink the lines for you, make it a little easier for you to do. All right, but we were supposed to start with a 3 1/2 inch line. And dividing it not into these segments, but proportionally to these segments. And Noah, what do we need to do first?
You need to draw a line underneath it.
Draw a line underneath it.
Like
Not parallel.
coming off of
Okay, coming off one end point. Draw a nice long line, but come off one end of the given line at an angle. Then what, Dylan?
Open up your compass to like enough where it would fit like 5 segments.
Oh, okay. If I had just been said divide into segments that are in ratio 2 to 3, yes. Since I said divide it proportionally to 2 inches and 3 inches.
Then measure the 2.
And to be fair, it would give you the same result. It really ought to, it would, but we use the lines we're given because again on a quiz or test you wouldn't necessarily know that they're 2 to 3, the ratio. Right? You just know I have these 2 lines or these 3 lines or these 4 segments, whatever. So this guy's got these 2 segments, so we measure the 2-inch line.
And mark it off on the line.
All right, and then Lana.
Measure the 3-inch line.
There, and
Put it
then
at the end of the 2-inch. And then
so mark that off in succession. Now this time there's only 2 segments. That's kind of nice. Usually we've had 3 every other time we've practiced it. So this one really not bad at all. Brandon, now what?
Connect the end of the 3.5-inch line to the last mark.
There we go. Go down to this last ending mark we made and connect that to the free end of the given line. Again, if you want to scribble that excess out there, could have done that at the far end of the big long line earlier. You scribble this out, scribble that out, just so you're not tempted to use it. If you need to do that, by all means do so. But coming back over here, then what do we need to do? You, Brecken, you at the face.
Construct the parallel.
Good, construct the parallel at this point here. So again, to construct a parallel, we
To mark the angle.
mark the angle. So we're going to come down here. Again, I've got plenty of room to open the compass now because the segments are so big. That's kind of nice. Measure the angle and mark it. And when we draw our parallel, we will have divided 3.5 inches proportionally 2 to 3. There we go. Now, how big would those pieces have to be?
1.5 and 2.
They have to be 1.5 inches and 2 inches. And did anyone measure to see if that's what they had?
I'm a little off.
All right, let's see here. I should have 9. No, I'm a little off. And then this would have to be theoretically 12, and it's a little big. So maybe my parallel may be a little bit off there. I'm not sure. Does it look parallel to you from your angle? Because I see everything from a weird point of view.
I'm
It looks
off
parallel.
4.
So I may not have measured perfectly or something, but all right, there's the steps. So that's what I'm looking for in the quiz or test, is do we have the steps? Have we followed the proper procedures there? Questions? One of the things I pointed out in the last lesson is that we can actually construct rather unusual fractional amounts using this method. Right? We constructed 2/3 of an inch, which no ruler that I've ever seen has thirds. I've seen rulers with tenths. Most rulers have 8ths and 16ths, or maybe even 32nds. I've never seen anything with thirds marked on it. But we can use these construction techniques to construct irrational values. So 2/3 is at least a rational value. What if I said I wanted you to construct a line, get out a blank sheet of paper, or if you have room there, that is square root of 6 inches long. The square root of 6 inches long. That's an irrational value. How am I supposed to construct the square root of 6? What is that anyway? It's like 2.3, 2.4, someone with a calculator. What is the square root of 6? I'm thinking 2.3. 2.44? So just under 2.5 inches. Construct the square root of 6. Well, if there's a square root class, the existence of a square root implies also then the existence of a square, perhaps an x squared. When have we seen an x squared, or when have we with proportions dealt with square roots? Mean proportional. Realize this line was supposed to be 6 centimeters because that's the mean proportional between 4 and 9 centimeters. What type of segments might I use if I wanted a square root of 6? Because I took the square root of the product, right? I said 4 times 9 is 36. The square root is 6. So that's how I got a 6 centimeter line here. Well, I want a square root of 6 inch long line. Was that, Abby?
2 and 3.
If I had a 2 inch line and a 3 inch line, like maybe these 2 and 3 inch lines that we still might have on our paper, if I used those, I could get the square root of 6. What's another way I could get a square root of 6? 1 and 6. 1 and 6 would do it. If you wanted to get really weird, you could use like fractional number. I wouldn't do that though. But yeah, 1 and 6, 2 and 3. 2 and 3 is probably the easiest way. So if you don't have it on your paper, maybe you set that paper aside, draw a 2 inch line and a 3 inch line on your paper. And we're going to use those. Now, again, this assumes that your markings on your ruler are accurate, but based on the markings made by your ruler, 2 inches and 3 inches, what we are about to construct will equal the square root of 6 inches. I'm going to recheck since my last construction was a little off. Uh, 2 inch line is a nudge too short. As is my 3 inch line. They're both just a tiny bit short. Oh well. I'll just have error again. I don't feel like adjusting, 1/8 of an inch. All right. So, anytime you're asked to construct a radical value, you need a mean proportional. Start though in constructing the mean proportional class by drawing a big long line again. Careful, the 2 long lines is for either a 4th proportional or the ever popular 3rd proportional. So Draw a big long line. At least how long does this line have to be, class? 5 inches. Now, what if Noah's back there sitting behind that camera all smug? He's like, he says 2 and 3. I'm gonna do 1 and 6. I do my own thing, man. Well, I don't know if he talks like that, but if he did. All right. How long would Noah's line have to be? 7 inches. Ah, so who's the smart one?
Me.
The people who use 2 inches and 3 inches, which is why Noah did that. Noah didn't do 1 and 6. But, oh, he did. Never mind. I'm just kidding. Anyway, so again, the idea is whatever you have. For instance, if I wanted to construct, let's say the square root of 10. Well, what 2 lines could I draw, class? 5 and 2 or 1 and 10? Which ones should I do?
2 and 5.
5 and 2. If I wanted to, now you realize 2.5 and 4 also gives you a product of 10, right? So I could do 2.5 and 4, and that would take you down from 7 to 6.5 inches. Not a huge gain there, but there's thoughts. Could I do 3 and 3 1/3? It'd be really hard to draw the 1/3 unless you had that saved from a previous construction. So, integers are my preference. I'd probably just go 5 and 2 if I were constructing the square root of 10. All right, so we draw our big long line. It's at least 5 inches long. Longer is better, only because we don't have to worry about running out of room. Then what do we do? Reckon?
Measure the 2-inch line and mark it off on the big long line.
Measure the 2-inch line. Mark it off on the big long line. And I'm trying to compensate by making my 2-inch line about 1/8 of an inch bigger than what the line shows, since I found it was slightly short. And then after that, Michael,
You measure your 3-inch line
measure the 3-inch line.
and mark it off on the big long line, starting where the 2-inch line is.
Good, so mark that off in succession. At this point, anything over 5 inches that you measured would be excess at this point. This is really random, Michael. Do you see my 2 arcs? If you compare them, curvature, barely noticeable curvature, bigger radius. Tying back into what we talked about with physics, mirrors, and lenses. Anyway, that's totally random, but I happen to see it right in front of my face, so, I've never stopped it. When something's random, that doesn't stop me. All right, what do we do now, Lana?
Then we do the perpendicular
Where do I put the perpendicular?
at the first mark.
At the first mark. So right in between the 2-inch and the 3-inch segments. Hi. Somebody was, I don't even know what that was. Some weird noise on the wall. All right, so construction 4, again, open the compass, make a little mark on either side, open it wider, marks, intersecting arcs above, and connect the dots down. By the way, since we've already calculated it should be around 2.5, when you draw your perpendicular, make sure you give at least 2.5 inches, okay? Give yourself at least 2.5 inches, because it's got to reach up that high at least. Now here's the next key step. Adam, what do we do?
That's when you make the bisector of the segments combined.
Of the segments combined. So I'm going to open up my compass, but I'm not going to open it more than half of this piece, nor am I going to open it more than half of this piece. I've got to think of this whole thing here. It's got to be more than half. Now, I don't know that I necessarily want to coincide with the previous existing arcs, so I may open it maybe here or there. I'm going to be able to fit down there too, though. So I may open it about here. Open it up, make your mark, go all the way to the far end, make your intersecting marks. Ooh, that just barely made it. And that. And again, all you really want here is the midpoint. The line is inconsequential. I'll draw it real lightly. Because this point right here, my midpoint, is the point that I'm after. And the reason I want that midpoint was to do what, Lana?
Draw a semicircle.
Draw a semicircle from start to finish. So measure it off. Now go ahead and check. Do you have a line segment from right here downward that is slightly shorter than 2.5 inches?
Mine is.
For me, 2.5 would be 15. I'm at 14 and a half. So I think I'm almost spot on in ratio to what the square root of 6 would be. Again, now again, you may need, for bigger radical values, you would need more space on the page. You might need a poster board and a compass that can open bigger than what you've got. But the point is, you really can construct any length you want now, including irrational lengths. Fractional lengths can be formed, dividing a line proportionally. Irrational lengths can now be formed. Okay, so this opens the door, this understanding of proportions, and then constructing them opens the door to constructing things that previously we could not have. Questions on this construction? All right, one more construction in this round. It's a short round, just 4 of them. Construction 20. Construction 20. Go and get out a sheet of reinforced edge paper that will go into your notebooks. Construction 20. And this is something I referenced when we talked about theorems 66 and 67. We're finally getting around to it here, and that's the construction of a polygon similar to a given polygon. Construction number 20 is to construct a polygon similar to a given polygon upon a given base. Construct a polygon similar to a given polygon upon a given base. Here's the fun part. We are all going to have different polygons here. But let's all at least agree to do a pentagon so we can follow similar steps here. Start with some line, however long you want it to be. Don't make it too big. And then draw some line at a slant on one side. Draw some line at a different slant on the other side. So whatever angle I made there, I'm going to maybe make this a little bit straighter up. In fact, I'm going to make it longer too, just to really mess with stuff. And then make 2 lines that come together to meet somewhere. Doesn't have to be pretty. Let's at least make it a convex polygon though. We don't want any reflex angles and such. And let's call it A, B, C, D, E. So draw some pentagon on your paper, call it A, B, C, D, E. Now, you don't want to overdo this next step. However big your AB is, make a slightly larger A prime, B prime, either off to the side or to the side and down. Give yourself some space. So don't put it right next to your old polygon. Give yourself some space, but draw a slightly longer line and call it A prime, B prime. That's my base. Oh, is that longer? I don't know, that's 9. And when I said slightly, I meant slightly, that's 11. It is slightly longer, okay. So draw a line that is slightly longer than your old base AB. So we're going to construct a polygon then that is going to be slightly larger. I've got 9 inches, 11 inches, so my ratio of similitude is going to be 9 to 11 for all my sides. All right, go down to the bottom third of the page. Step number 1, draw all diagonals from one base vertex. Draw all diagonals from one base vertex. I usually use the bottom left vertex. I usually go with my whatever vertex we call A. And we're going to draw all the diagonals. Well, obviously we could draw a diagonal from A to D. We can draw a diagonal from A to C. Remember, if you go way back to the beginning of the year, we said for any polygon of n sides, you can draw n minus 2 diagonals. Well, or for n minus 2 triangles, n minus 3 diagonals, excuse me, n minus 2 triangles. They have 3 triangles formed. And what I want to do is I want to construct these 3 triangles similar triangles rather, similarly placed over here to get my new polygon. So step number 1 is to draw all the diagonals from one base vertex. We've done that. Step number 2, copy all the angles at that vertex. So I'm going to number these angles 1, 2, and 3. We're going to copy all the angles at that vertex. But I'm going to show you a way to do it that is efficient, because we're lazy. Copy all the angles at that vertex. Again, if I had 7 sides, I would wind up with 4 diagonals, which means I'd have 5 angles, right? I've got 3 angles here. What I'm going to do is I'm going to open my compass as wide as I'm allowed to. I'm kind of limited by the lengths of AE and AB, and make an arc that just goes all the way through. Ooh, that just barely made it. Once you've made this arc that goes all the way through, go to A prime and make that same arc. What I'm going to do then is I'm going to start by measuring my smallest angle, or my first angle, angle 1. So, measure across. Mark it across. Now remember, the smaller your compass is open, the harder it is to be accurate. We've seen that, we've experienced that throughout this year, correct? Let me tell you what we're not going to do. What you're not going to do is you're not going to open your compass now and measure angle 2. You're going to measure 1 and 2 collectively, because that's easier and more accurate. So we measured 1, we marked it off. Now I'm going to measure 1 and 2 together, collectively. I'm going to mark that off. This does something else. It keeps me from accidentally, if my first mark is a little bit off, it keeps me from messing up the second one by default. Okay, so if I always go back to this base AB line to measure across 1, measure across 1 and 2, then to measure across 1, 2, and 3, I can get it, to measure across 1, 2, and 3 together. Well, now if I messed up the first 2 lines, it's not going to throw off my third line, right? Every line gets a fresh start, or every angle gets a fresh start. That's going to be your best bet. And then, of course, we connect the dots, right? We're copying these angles. When you copy the angles, make these lines nice and long.
We put that as step 3.
This is part of copying the angles, right? So copy the angle is make an arc, measure across, mark it across, connect the dots. So this is the connect the dots part of that. By the way, in parentheses, C-3. C-3 is step 2, is how we do step 2, copy the angles. At this point, we've done so many copying angles, I don't think you're going to have to refer all the way back to construction 3 to be like, now how do I do that? Shouldn't be the case. And if I wanted to, I could go 1, 2, 3, so I can see my 3 angles there. But draw these lines nice and long when you draw them. Longer than you think they need to be. All right, so step 1, draw diagonals from one base vertex. This forms a several angles, or in this case, a few angles. Number 2, copy the angles. Step number 3, copy the angle at the other base vertex. Copy the angle at the other base vertex. In our case, this is angle B. We're going to copy angle B. So make the arc. Make the arc. Now, this is where students start to lose it a little bit. So look up this way real quick. Make sure when you measure the arc, again, ignore the noise. These diagonals don't affect anything. This arc doesn't affect anything. You're focused on this arc. And from this point to that point, that's what you're measuring. So tune out the noise, like shooting a free throw. Measure that arc. Come down here, ignore the same stuff. Don't worry about diagonals. Don't worry about anything else. Just measure across. And remember, when you connect the dots, you're connecting back to B prime, because we were copying the angle at B. Again, make this line nice and long. Now, I have had students comment before, Mr. Nadasky, I don't understand. Over here, my arc crossed over the one diagonal line. And here, it didn't. What did I do wrong?
Extend one.
Class, what's the answer?
Still not.
What?
It's a longer line.
This base is longer. Everything about this picture is going to be bigger. Therefore, these lines are further away. So yeah, it's not necessarily going to have to cross over the lines the same way. So yeah, don't worry about, hey, this crossed over a bunch of stuff. Hey, this didn't cross over as much. That's to be expected. Now, do you see on the picture here, this first diagonal formed by angle 1 and this side BC come together at vertex C? Do you realize that's already happened over there? This point right here is C prime. So go ahead and label it. That point right there is C prime. So of our 5 vertices, 3 have already been found. Step number 4 is kind of a vague step, but it's copy angles at top vertices in succession. Copy angles at top vertices in succession. Whew, and Dylan's just barely fit on his page. Didn't make it by much, but it did make it. Lana's looks like she's getting into her other construction. She didn't go down far enough. Should have gone down and kind of off to the side at the same time. It's okay. It's your first time doing it, right? So we learned some lessons from it. Now, here's the thing. The angles at the top vertices. Do you realize, class, that this little angle, if I wanted to call it 4, angle 4 is already in the picture, right? But angle, if I want to call it 5, angle 5 isn't yet. Does everyone see that if I were to copy angle 5 right here, I would get the line that hits to the next vertex? You could copy angle 5. I would suggest copying the whole angle at C. Because if you copy the whole angle at C, it's bigger. Bigger is easier. So I'm going to go ahead and make my arc so that I make an arc that hits the whole angle at C. Now in my case, that's a slightly obtuse angle. That's okay. I like bigger angles. It's just easier to work with. So I make my arc here at C. I make my arc here with the point of the compass at C prime. Then I measure, again, tune out the noise. All that matters are these 2 points right here. The place where my arc crosses BC and where it crosses DC. I'm going to measure from where my big arc crosses BC to where it crosses DC. Come here to B prime, C prime. Make the little mark. Again, it's not wrong if you copy 5. I just like the biggest angle I can possibly get. And right here is D prime. Only one angle left. Only one vertex left to find. And do we all see that if I were to copy this angle 6 from this diagonal, I could get my side DE, or D prime E prime, or I could copy the whole angle at D like I did last time. I'm going to choose to copy the whole angle at D, referring back to this line. Now, you could make an argument. It might be better to go off the A prime D prime line, the AD, right? Only because this line is the result of a couple of different angle measurements, right? This one is just the result of one angle measurement. So this line is more likely to be accurate. But again, potentially you might have a really skinny little angle right here. D is going to always be bigger. So I'll measure D, but again, it's not wrong to measure 6. All right, so making the arc then all the way across D, and making the arc, losing it, all the way across D prime. So it intersects DC and D prime C prime. measure across, measure across, connect the dots. Tons and tons of angle copying going on here. And there's my E prime. And if you look at your paper or you look at the board and you see, wait, A, B, C, D, E, A prime, B prime, C prime, D prime, E prime, you can tell they look exactly the same except the second one's bigger. How'd you do? Do yours on your paper look similar? They should look similar to each other. That looks pretty good and very unusual too. Good and nice and unusual. Very weird and very good. Excellent. You took me up on it. None of that Pentagon building in Washington, D.C., regular Pentagon nonsense. Yeah, looks like we did. We missed the angle going over to E. Alright. Good. Yours doesn't look too bad. Yours actually looks like a pretty normal looking polygon. Oh, okay. So right here, right, you went. What on earth is this line?
Yeah, that's what I'm trying to figure out. I had it now.
Because what you did was you went to this line, whatever it was, and we should have. Okay, so right here, this line is off as well. I feel like proportionally your C should have been higher. No? That's right. So your whatever angle you copied to get your CD wasn't right. And then D, again, whatever angle you copied should have come down, and it did not. You measured the angle from this line, or something didn't measure quite right. But you see that though.
Yeah.
All right, because we're going to do it again here in just a minute.
Oh my.
Flip the paper over. And on the back side, if you would, go ahead and draw now a quadrilateral, but don't make it look like a rectangle or a square, or try not to even make it a trapezoid. Try to draw something weird for your quadrilateral. So I'm going to start with some baseline here. And I'm going to make my baseline pretty big. And I'm going to come with a side that kind of goes out a little bit. Make another side that goes out a little bit more and is longer. And then I'm going to connect across the top so that nothing is parallel. And I don't think anything is equal. It's just a big nothing that we will call A, B, C, D. This time, draw a slightly shorter base. So however big your AB is, go a little smaller this time. And call it A prime, B prime. Got it, or do you need help?
I need help.
Yeah. Didn't get that on the recording, did we? Said it too quietly. Just play it over and over again. Nothing. All right. First things first, class. We need to draw a diagonal. I could either draw BD or I could draw AC. Which one do you want to do, Dylan? BD?
Oh.
All right. We're doing it backwards of what we did last time, and that's fine.
Only because if I do AC on mine, it would look like thing.
I'm going to number these angles 1 and 2. What do I need to do, class?
Copy what it is.
Copy both angles. Copy angles 1 and 2. So go to B, make the arc. Go to B prime, make that arc. Measure across angle 1. Mark it off. Measure across 1 and 2 collectively is my advice, not necessary. You could do angle 2 on its own merit, but I think you're going to be more accurate if you do 1 and 2 together. Make your arc, and when you connect your dots, draw the lines nice and long. You don't want to have to extend lines later. That is really annoying. I'm going to relabel the angles 1 and 2. Then what do we need to do, Abby?
Then you copy the A.
Copy the angle at A. Whatever base vertex you ain't used yet, use that one. again, tune out the noise of arcs crossing each other, arcs crossing extra lines, and weird stuff like that. Don't pay any attention to it. Notice since I went smaller, this arc never hit the diagonal the first time. Now it went way over the diagonal. Well, that's because you're dealing with a smaller polygon, or what's going to be a smaller polygon, I guess. And we've already located then, once we've done this, we've located right here, vertex D. So we've got our bad triangle already complete. We actually only have one vertex left to go. You can either copy the whole angle D, or you could just copy angle 3. I'm going to do the whole angle at D. You can see that none of the steps are hard, but this construction, more than perhaps any we've done so far, forces you to focus on exactly what you're supposed to be doing. There are a ton of distractor marks built in. And there's our two similar polygons. Again, created by, with the use of equal angles, making similar triangles similarly placed. How do we do on the quadrilateral? Do they look similar to each other? Good. Good.
I was behind.
Oh, you never drew the... Okay, we want to copy this angle as well. So do you see how on mine I've got an angle 1 and an angle 2? I measure angle 1, mark that off, and then I measure the 1 and 2 collectively. We did the 1 and 2 collectively, but we needed that diagonal angle as well. A bit of a diamond. Good. Yours looks really weird. Good. Good. Good to say when I encourage weirdness. Y'all don't let me down. That's good. All right. Your homework this evening is to complete a small handout. It's got one more pentagon for you to practice. So I know you've done one of these already for the notebook. I've already given you the given line, but this will help you to see the way it would appear on a quiz or test. So to complete the small handout, it's in the description of the video, Gavin, so that you can complete that. This is not part of your original handout packet. So the handout that is in the description of the video is what you'll want to complete for homework this evening. All right, we'll practice more of this in our next lesson. Have a wonderful rest of your day, and you are dismissed.